Hi, so in our next tutorials we're going to build components from scratch on top of ROS, the robotic operating system. So you need to have a basic understanding of the major ROS components. So if you are already familiar with ROS, you can skip this simple tutorial, but if not, this will be a great jumpstart for you to see things in high-level view and then continue on to the ROS tutorials and learn more. So let's start by discussing ROS installation. Today we have two major versions of ROS, ROS 1 and ROS 2. ROS actually exists for 10 years now, and up until recently we had different versions of ROS 1. And ROS 2 is now a new version, which is in some ways more robust. You need to remember that if you build a robot using ROS 1 components, they cannot communicate with ROS 2 components, so you are restricted to the version of ROS. But please note and remember that by using Nimbus, it really doesn't matter because we use Dockers. So you can actually build your robot where some of the components are made of ROS 1 components and some others are of ROS 2 and others might not be from ROS at all. So how does ROS work? ROS applies something that is called a computation graph. We have these nodes. These nodes are called ROS nodes. Each node is basically a process that applies something else. So for instance, this node can read some sensor input, and this node can calculate something, and this node perhaps can issue commands to some actuators, and so on. These nodes communicate through things that are called ROS topics. So one node can publish a topic, and other nodes can subscribe and read its data. So for instance, we have here a wheel odometer, and it publishes a topic called /odom, okay, short for odometry. And here we have a node that is a path planner. So it gets the odometry input and perhaps plans some path for the robot. And it publishes a command velocity topic, which could be subscribed by the motor control and then applies to the robot actual actuators and move the robot around. And let's say that the odometry data is x, y, and z axis values, and the command velocity has how much speed to go forward and, let's say, z return. Another example would be a talker and a listener. So this is straight from the ROS tutorials. We have a talker node which publishes a chattered ROS topic, and it's from the type std messages standard messages .string, and the listener node actually reads these messages. So we're actually going to take this example in our next tutorial and upload this to Nimbus. Here are some useful command line tools to actually locate, see the ROS nodes and the ROS topics, and etc. So ROS node list actually lists all the active ROS nodes, and you can type ROS node info / a certain node, a specific node, and see the node's information. With ROS topic list, you can list the ROS topics, and with ROS topic info, you can see the info of a certain topic. And with ROS topic echo, you can actually see the data that is written to a certain topic. With ROS topic pub, short for publish, you can publish a topic and you can state its name, for instance, a chatter, and the type, let's say std messages.string, and the specific data that you want to publish, and you can use the tab for auto-completion, and this is really, really useful. So how does the subscriber actually knows the publisher? So ROS applies something that is very similar to the service-oriented architecture. We have this node called ROS Master, so it's a really important node. And it does all the bookkeeping. It knows which nodes are active and which topics are issued, and so on. So let's start with the publisher. The publisher connects to the ROS Master node and states, I'm publishing a certain topic at localhost and some port. And the subscriber actually connects to the ROS Master and states, I would like to subscribe to some topic. And since the ROS Master has the information, it can reply node 2 with the specific information on how to connect. And once node 2 has this information, it can request data from node 1, and node 1 can reply the data, and this is how they connect. So now these nodes have peer-to-peer communication, and they don't need the ROS Master anymore. If you do want to connect to the ROS Master, it has a fixed location given in the ROS Master URI, which is typically at localhost at port 11311. If you want to run the ROS Master to launch it, you can either write ROS core in your terminal, in the terminal connected to your robot, of course, or use the ROS launch command. So now when you have these nodes, you can of course package them with a thing called ROS Package. So let's say these nodes here belongs to a package of the leader, and this package here, it's an Xbox controller package, and so on. So ROS has a lot of packages. It's very similar to code libraries, and you can of course download these different ROS packages and use them, and we'll do so in our next tutorial. So as you can imagine, some of these nodes read sensor input, some of these nodes calculate some things, and others apply something to an actuator, and so on. And some of the nodes can publish a certain topic, and other nodes can subscribe, and we have this computation graph which runs the robot. So now we need to create a ROS workspace. So you can just apply make dir, you're making a directory called Cogniteam workspace/source. Then you can go into this directory and apply Cogniteam make. So Cogniteam make will actually use cmake in order to create a template folder for your workspace. And you will have these subfolders, build, devel, and source. And I'll invite you to go to the ROS tutorials to learn more. So in the next tutorial, we're going to use the talker and listener straight from the ROS tutorial and upload it to Nimbus and use it as Nimbus components. We have the talker and we have the listener, and they're writing STD messages from one to another. So see you in the next tutorial.